Today we begin the computer hardware unit, and we've broken this unit down into 3 chunks. We're going to start off pretty small by introducing computer hardware and the aspects that we're talking about. We're going to talk about motherboards as well as central processing units. So it should be a pretty straightforward lesson. Now, every computer is made up of a ton of different components, but there are a few components that are definitely more important or have a higher priority than others. So when you're deciding on whatever computer you are going to buy, these are the main aspects you're going to look at. Everything else, for the most part, support these things. So for example, a lot of people say, well, you need the right power supply unit. Yeah, you definitely do, but that depends on these components that you're choosing. Right, so we're going to look at these 5 major components and dissect them throughout the whole next 3 lessons. Right, so let's start off with the first one, and that's the motherboard. For every one of these components, you're going to see 4 sections, and these 4 sections are the important information about these components. Now, you should also know and be able to recognize what these components look like from their picture. Now, the one you see up at the top there, it's a pretty standard looking motherboard. The big white square here is typically where the CPU will go. These 4 long pieces are where you're going to put our memory. These are ports that are on the outside. And over here are, sorry, I lied. These are the ports that are where the memory is going to go, your RAM ports. And down here on these ones, these are typically going to be where you're going to plug in things like graphics cards and stuff like that. So yeah. Let's move on. First of all, the motherboard, or Mobo for short, although I've never actually heard anybody call it the term Mobo before. That is I guess the short form for it. So each one of these are going to have a human body alias. After all, the computer is very analogous to the human body, so we're actually going to use that as our tool. So the motherboard, its human body alias is our spine, or our central nervous system. And the reason why the Mobo is often called the spine of the computer is because all the devices, everything plugs into it. It is the nervous system. It's that spine of the computer that everybody plugs into. And then all the information travels along it to the next component. So if you want to send information to a component, you don't have a direct connection to that component. Your information goes to the motherboard and then through that component. So what is the motherboard? It acts as the focal point, the focus point that all hardware connects to so that they can communicate with one another use each other's functionality. Now, of course, how does it actually work? Well, mostly just circuits and cables. All these connections are just a combination of circuits and cables that connect each device together. The motherboard, as I said, it kind of works like the central nervous system. When your brain tells your leg to kick, well, there's an electrical signal that travels through your central nervous system down to your leg, and then that causes the muscles to contract. The computer, the motherboard, works in a very similar way. When one device wants to connect and discuss and communicate with another device, the signal is sent from that first device to the motherboard and then flows along the motherboard through the circuits and cables and whatnot until it gets to the end result, which is destination. Now, every one of these components are going to be located somewhere within or outside of the tower of the computer, the base of the computer itself. Now, the motherboard is an internal component, which means it's actually inside the case. All right, and it's typically bolted directly to the case itself because everything kind of sticks to it. All right. So moving on, we get into what most people know, a central processing unit, or CPU for short. Now, this is the thing that does all of the thinking per se. So the human body alias for this is the brain. What that means is it makes all the decisions. It doesn't really make decisions, but it kind of simulates the idea of making decisions. In reality, it does very little. So what does it do? Controls the functionality and thinking of the rest of the computer. Well, what does that actually mean? Well, it deals with data, information, and all it can do with that information is kind of distribute it, or help distribute, I should say. It can compare data and it can add data. Those are the 2 main functionalities, adding and comparing of information. So how does it actually work? It interprets and manipulates mathematically, that's the addition and the comparisons, a computer language called binary. That's what it really does. Interprets and manipulates computer language called binary. What is binary? We'll get to that soon enough. Now the CPU, it's all about speed. And the faster we want something to operate, we want to have the shortest connection possible to that motherboard so it can pass information. When you plug something into your motherboard with a cable, well, all the information has to flow through that cable. So the longer the cable, the longer the travel distance. So anything that we want to run super fast is going to be connected directly to the motherboard. The CPU is one of those things. So a computer chip is directly connected to the motherboard. And we saw a picture of where that went in the first image of the motherboard. So let's talk about the speed. A lot of times you'll hear people say, oh, my computer is this fast, or my computer is this powerful. Typically what they're talking about is the speed of the CPU. And we measure that with the term frequency. Well, frequency is a measure of something over a period of time. In the world of in the world of computers, it's the number of operations a CPU can do in a single second. And again, a CPU only does two things, additions and comparisons, most of the time. So that's what it's measuring. Frequency is how many operations a CPU can do per second. The unit of measure we use for that is something called hertz. H-E-R-T-Z, right? Typical measurement for frequency. So this chart below compares different units of measure for hertz. For example, kilohertz, megahertz, gigahertz, and terahertz. You'll notice that each one goes up by a multiple of 1,000. So a kilohertz is really 1,000 hertz. A megahertz is 1,000,000 hertz. A gigahertz is 1,000,000,000, and a terahertz is 1,000,000,000,000. Now, when you think about what this actually means, what we're saying here is that a computer that has a CPU with a frequency of 1 gigahertz, that means it can do 1 billion operations per second. Now, you think, wow, that is extremely fast. It really is, but the thing is your computer does a lot of different operations, and the more programs you have running on it, the more it's going to require. So what do all these numbers actually mean? Now, on the right-hand side there, I have an image of kind of like a CPU monitor, and you'll see that it has those labels right in the middle there of CPU 0 through 7. So what it's saying is that there's 8 CPUs in this one computer, kind of. It tells us that's what it is, but that's not really the case. It also tells us the frequency right here. The frequency is 3.5 gigahertz. That means that each one of these CPUs operates at that speed. So 3.5 gigahertz, well, we said 1 gigahertz is 1 billion operations. So that means 3.5 is 3.5 billion operations per second. But that's not just one of the CPUs. That's all of the CPUs. So every single one of those CPUs is doing 3.5 billion operations per second, in theory and on paper. In reality, it's not quite like that because there's other things that come into play. And it'll be a little bit less than that in actual practical terms. So let's take a look at the actual text here. Put another way, a computer running at 1 gigahertz can perform 1 billion operations per second, as we already said. Modern computer CPUs typically are made up of multiple cores, as you see in this picture here. So what this means is that that a CPU is really a group of CPUs on a single chip. So a lot of like Intel i5 processors are typically dual core. That means that there's 2 chips on it, 2 cores. So that would mean over here you would only see CPU 0 and CPU 1. A lot of them, the most common CPU would be a quad core though, and a quad core would have 4 cores. All right, there's octo cores as well, and there's even more than that depending on the device you're working on. So let's do some examples. Sometimes I may ask you to calculate the speed of a computer, and I may tell you something like, it is a quad core that runs at this frequency. How many operations per second can it do? What is its frequency? Or frequency would be measured in hertz, or I might ask you for operations per second. So let's do a quick example. Doing a quick search on bestbuy.ca, we can see that an average computer is a quad core CPU running at 3.2 gigahertz. This means that it has 4 CPUs, each of them running at 3.2 gigahertz. So the math says, well, if I have 4 of them, then I say 4 times 3.2, which is 12.8 gigahertz, or roughly 12.8 billion operations per second. That's quite a bit faster than than 1 billion operations per second. So you can see how the multiple cores actually help this thing. So as a frame of reference, this is a little throwback here. When Mr. Lane was in grade 11 back in 1997, the olden times, he had a CPU in his class. I worked on a computer that ran at a whopping 33 megahertz. That means that it did 33 million operations per second. It seems pretty quick. But if you compare that against the average computer that we just talked about above, that's 1/390th of today's average computers. That means if something takes you 1 second, it takes me 390 seconds. So that's over, what is that? That's over 6 minutes for something that takes you 1 second. That's a big difference. It's a huge difference. Don't worry though. We had a turbo button on our computer that if we pressed, it went up to 66 megahertz. Still terrible. Still completely terrible. But evolution of computers keeps going, and our computers keep getting faster and faster and faster. So that's the end of this first module. And the second one coming up.